Okay. Good morning. My name is Cassidy Ellis. I'm Local Government's Program Manager here at the Southcentral Partnership for Energy Efficiency as a Resource, or SPEAR. And today I'm glad to host another of the City Efficiency Leadership Council webinars. And really excited about our topic today. We are joined by a longtime partner and friend of SPEAR's, Gavin Dillingham, to talk about CHP, and then a new acquaintance in our circle to talk about a specific case study and project. So really happy to have both Gavin and Doug join us this morning. Before we jump into the presentation, just a couple of quick announcements. We do have a lot of new names and faces this morning. So just a brief overview of the CELC program. We are an outreach and education program of the State Energy Conservation Office. That is the Texas State Energy Conservation Office. And CELC is really focused on sharing of best practices, resources, and information about energy management and other topics related to energy and resource use. We do this through these webinars, through development of resources, through regional roundtables, and other technical assistance. If you're interested in learning more, I will follow up this webinar with an email with my contact information. Reach out to me if you would like more information. Couple announcements for today. So it does look like our next CELC webinar will be on February 25th, and we will be going through Lone Star technical guideline updates. For anyone who's not familiar with Lone Star, it is a low interest revolving loan fund for energy and water improvement projects operated by SECO. And there have been some updates to the technical guidelines. This is, we're about 90% confirmed that this is when and where we're going to do this, our next webinar. Some of you may be familiar with the Energy Services Coalition. It is an industry organization of energy services companies, public entities who are working on performance contracting or other energy services projects. I'm involved in the Texas chapter, and we are having our next meeting on March 3rd, 1 to 3 p.m. You do not need to be a member to attend those meetings, and it should be interesting. For any public entities in the more urbanized areas in Texas, just a reminder that your local government energy reporting is due February 1st, that is Monday. But we are hearing from a lot of affected jurisdictions that with everything going on with cities, they do need a bit more time. Extensions are available. Just reach out to me and I can get that extension over to SECO and we can get that confirmed for you. We also have a recording of the webinar we did on local government energy reporting and the details, backgrounds, deep dive into it. It's a really helpful resource, and a link to that recording will be in the follow-up email as well. SPEAR is hiring. We have openings for part-time positions for an administrative assistant, bookkeeper, and a codes program analyst position. Those are close to closing, but if you know anyone or are interested, again, that information will be included in the follow-up email. And finally, today's webinar does qualify for International Code Council CEU credits. If you would like to receive an ICC CEU, you must fill out the webinar survey following the presentation. If you are calling in from a phone and your name is not showing up associated with your attendance, then you do need to let me know that you were signed in from a phone so that I can make sure you get the credit for attending. If there are any other announcements, please put those in the chat. So you should all, yes, we do have a chat. If you would like to let the group know anything, or if you have any questions, please put those in the chat box. And finally, we will be doing question and answer at the end of the presentation, but if you have questions during the presentation, also put those in the chat. So with that, I am going to turn it over to our presenters for today. Today we have Gavin Dillingham, Director of the Department of Energy's Southcentral CHP Technical Assistance Partnership. As I said, Gavin has been a longtime friend and associate of SPEAR, and really glad to have him present today. And then glad to welcome Doug Edgar, VP of Operations with White Harvest Energy, who's going to tell us about a project that partnered with the DOE CHP TAP program to develop a system for a university. So with that, I am going to stop sharing and I'm going to let Gavin bring up his presentation and introduce himself.
All right, do you guys see the speaker screen or the presentation screen there?
We are seeing the speaker screen.
All right, 1 second. There we go.
There you go.
All right, thank you, Cassidy. Always a pleasure to be working with SPEAR on the CLC project. And so thank you for the opportunity to come speak today. Today, what I wanted to do is really kind of cover some things specific to what we're seeing across the public sector with growing interest around resilience and microgrids. And I think there's just some great opportunities to start discussing, especially we see the continued kind of development of CHP technologies and their applications across a variety of different types of resources. And then also just how CHP is can really be seen as a way in which to better integrate renewable energy, especially when you're looking at solar plus storage systems. And so we're actually talking with some cities now about the opportunities of kind of solar storage CHP type microgrids being deployed for both emission reductions as well as resilience purposes. So excited to have an opportunity to come here and then have Doug, who's been a partner with us for quite a while, to come and talk about a university project that they've been a key part of there. So just give you a quick overview. We talk about CHP in general. We have a good sized audience here. I think when we saw the registration, it was close to 150 or so. So some of you may know a lot about CHP, some not so much. So give you an overview on that. CHP and microgrids, talk about how those are kind of being deployed and used, CHP and resilience. Doug's going to come in and talk about Wesleyan University and how that project has been developed and managed over time, and kind of what's been happening with that project. A great one up in Fort Worth. Working with CHP TAPs, and then kind of some Q&A there too. So a quick CHP overview. For those of you that are kind of new to the CHP space, also known as cogeneration, combined heat and power. It's a type of distributed generation or distributed energy resource where all the power is actually placed on site, as well as the thermal components of the system there. So most CHP systems are fueled by natural gas. Predominant number are across the United States are natural gas-based systems, although we are seeing a growing number with biogas and biomass, especially on the biomass side, for places that are more concerned with forest management or have a large amount of kind of biomass available for there. But in Texas, predominantly natural gas systems, although, as I said, there's a bunch of fuel flexibility there. Prime movers there, these are just, and I'll show you some examples of different prime movers in a minute, but those are the ones that are fueled by the natural gas, turn the generator and create the electricity. The efficiency benefits, the emission reduction benefits that we see with CHP is largely on that heat recovery side, where instead of using a boiler or maybe a electric chiller, you can use the thermal there to do a variety of additional processes. If it's steam, hot water, space heating, using absorption chillers or steam-driven chillers for space cooling, process cooling, refrigeration, sterilization, dehumidification, and a variety of things there. So really allowing you not to waste that heat and have a way to use it for useful purposes there. As far as CHP systems, there's a very wide range of these systems available. Traditionally, when people think about combined heat and power or cogeneration, think of large industrial sites, and it's true along the Texas Gulf Coast. There's a significant number of CHP systems that are operating down there, and some of them, and most of them, are very large. However, now most of the systems that we see now or that we're looking at are typically 1.5 megawatts And we're seeing a lot that are much smaller than that now. And we've actually seen applications of CHP going into residential homes where they replace the domestic hot water heater and are actually used there to produce hot water for the house as well as electricity. Those are just, of course, coming to market, but it just kind of shows you that wide breadth of system sizes there as well. So what are some of the key benefits of CHP systems? Of course, they're more efficient because you have that that generation that's coming there with the electricity, and you also grab the heat and cooling. Also, you don't have that line loss that comes when you're looking at more grid-based power systems come in. So you don't have to produce as much energy to have it at the used point. There are lower operating costs typically, a lot of different ways in which you can fund CHP. So we're going to talk about that in a minute as far as third-party ownership, as far as direct kind of capital expense ownership there. Reduced emissions, once again, because typically you do not have to produce as much power to have the power on site, as well as typically, and still most grids now, CHP natural gas burns cleaner than the overall grid there. And then largely what some of the areas that we're finding greater interest is on the reliability and resilience side of CHP across communities, as well as with utilities. And utilities who've at one point been kind of unfriendly to CHP, just saw it as a competitor, are now really looking at it more closely because they see it as providing this non-wire alternative, this opportunity to improve the grid, improve grid reliability and resilience without having this enormous outlay of cost to kind of grow the grid or build out the grid there. So some great benefits across the board there. Just to give you a quick overview of this existing CHP capacity. As traditionally the case, most of the capacity, which is just the gigawatts out there, are in the chemicals, refining, pulp and paper, industrial space, and that's just because they're just such large systems. But when you start looking at what's happened in the last few years, especially between 2015 and 2019, been almost 800 installs, and you look at the numbers that are coming in there, and a large majority of them are out of schools, multifamily, hotels, hospitals, office buildings, college and universities. You're still seeing a decent number of industrial installs and kind of your traditional installations happening there. And you're still seeing a large number of those large systems coming in there. But for the most part, you see a much growing diversity of CHP installations happening. And it's just real kind of exciting to see that space grow. Most of the studies that we're doing now, so I'll talk more about kind of some of the what we do as a TAP a little later, but a lot of the studies that we do, technical assessments that we do, have been in the multifamily space, have been in the hotels, hospitality space, a lot of stuff in the K through 12. I know a few energy managers are on this call that we've actually worked with in the past, that we've looked at CHP systems that are being implemented, wastewater treatment plants, et cetera. So just a wide diversity that we're looking at these days. As I mentioned earlier, the utilities are becoming a lot more friendly to CHP plants, and a lot of that is because it really helps support the reducing congestion and improving reliability on the grid. They also see it could potentially fit within the energy efficiency portfolio, and so you can talk with your utility to see if they're willing to provide incentives and rebates. Some utilities are more willing than others, but those incentives and rebates are available. But once again, they really see it as a distribution system resource or a non-wire alternative that really kind of helps with grid stability and alleviates grid congestions and helps with deferring the investments there. One of the things just real quickly to cover here is traditionally when we've talked with folks about CHP systems, one of the key areas is, well, I just don't have that type of cash available. I don't have the capital available for that, or I'd rather spend that money in another purpose versus buying a CHP system. That being the case, we're seeing a lot of third-party ownership type options becoming more available. If it's an energy as service agreement, there's power purchase agreements, there are lease financing agreements. A variety of them becoming more available, and there's new organizations that are actually forming that help kind of facilitate that. The DOE actually came out with the financing accelerator that helps kind of point you to, who are the people that are willing to kind of fund these projects or willing to own these types of projects, to kind of take that off your balance sheet, take that off a capital expense, and make it more of essentially a utility expense. Texas PACE, many of you may be familiar with the Property Assessed Clean Energy program across the state. Texas PACE would be another way in which you could own and operate one of these systems here as well. But in any case, some great opportunities to continue to own these systems without having to do the major capital outlay that has traditionally been associated with these here. One thing just want to really quickly point out, we're not going to read through all this slide, but we're seeing growing interest in the use of absorption chillers with CHP. For some of you that have been in the industry a while, absorption chillers have typically maybe not been as reliable. They've been a bit more expensive. They've had a tendency to kind of crystallize. They've been just too large for the application. There's been some pretty significant advances in the absorption chiller technology recently, where a lot of those issues have gone away. And so it's being seen now across commercial spaces, as well as just where that cooling demand is needed, a growing interest in that regard. And so in any case, it's something that we're definitely now considering more in the technical analysis that we do, just due to the price points and the reliability and improvement of these systems. So just want to keep that in mind, that it's not all just heat-related thermal applications there. Quickly want to go into CHP and microgrids. So microgrid is really just a group of interconnected loads and distributed energy resources, kind of have clearly defined electric boundaries, and kind of acts as a controllable single entity there. And so you see here just a quick little picture here showing all the different assets that are associated with the microgrid. As I mentioned earlier, we're doing a lot of stuff on the solar and storage side, where people are looking in ways in which to actually integrate CHP or integrate additional renewables, maybe to meet climate action planning goals or some sort of emission reduction planning goals. So we're starting to look at solar plus storage for that. They see the intermittency potentially that happens with that, or may not be able to cover the full load or as much of the load of their site as they would like to cover. So considering combined heat and power there to kind of provide that 24/7 kind of base component of there is one piece that's definitely being considered. One of the other things with CHP plants is really you're seeing them become a lot more flexible in their operation. Typically, when we thought of CHP, it was something that did operate just 24/7, strictly operating at the same amount, same load all the time. We're now seeing growing opportunities here where they're actually being flexed to some degree to deal with demand management, demand response, load shaping, load shedding purposes there. And a really good example here in Texas is what's happening over at Rice University. They have 2 CHP systems where they very much play in the kind of the volatility of the ERCOT market there with their CHP plant, where they've flexed one of their systems up and down based on demand or based on price volatility in the market and such. And so just seeing growing opportunity to generate additional revenue, or at least help pay down the cost of these systems by identifying other ways in which these can provide a benefit to the site there. But in many ways, the CHP system is really kind of that base component of a microgrid as they're being developed, and as storage continues to be deployed and increases its capacity as well there. So anyway, some great opportunities in that regard. Just quickly, some of the issues that are really driving this, looking at what is really driving microgrids here. Of course, the clean power component, when you can integrate the renewables in there and have a significantly more clean microgrid, that's key. The costs are coming down. Are they at price parity all the time with the grid? Not necessarily all the time, but when you look at the long-term life of these systems, and as well as the resilience benefit they provide, they really start making some great economic sense in that regard. Some of the other issues that I've kind of alluded to earlier is the reliability and resilience that we're starting to see, or that's really becoming a growing interest of communities, as well as critical infrastructure and as well as utilities, providing some great benefits there. And as I mentioned earlier, the renewable integration is also a key piece of that. So that's just really something to keep in mind, especially cities that are on the call that are looking at climate action planning, where you want to both reduce greenhouse gases, but you also need to maintain critical infrastructure resilience. You can essentially do both when you're looking at CHP there. Just kind of alluded to this a bit earlier, but just wanted to kind of further emphasize that not only CHP systems, but these CHP-based microgrids are largely being looked at as far as kind of a microgrid as a service type component, where you do not have to own and operate these systems. You actually act as maybe a host site, and a developer comes in and actually does a power purchase agreement or some other long-term contract with you to kind of set up that CHP system. Siemens, and we're not advocating for any organization, Schneider Electric, Power Secure, who's on here as well, but they did a real nice job as far as just kind of explaining or kind of giving an acronym to how they do a software or a microgrid as a service. And they have DBOOM, design, build, own, operate, maintain. So DBOOM there is just a nice little acronym, and that's where you kind of see in a lot of the growth happening in the market to some degree, is really kind of that overall third-party ownership piece. One of the keys just wanted to really get into and really emphasize the importance of is really that the electrical disturbances that we continue to see increasing across the United States, really seeing a growth in outages. When you looked at the most recent NOAA billion-dollar events, I'm sure some of you have seen those, where NOAA has on a yearly basis been tracking the billion-dollar events. There were 22 of those events across the United States in 2020, so $22 billion plus events. 11 of those were in Texas. A lot of those were hurricane-based type impacts there, so which led to some significant power disturbances there. In any case, we're seeing some growing in number of power outages, and those power outages can be costly. And this is just a list to give an example of how much it would cost at different variances of hours, from momentary to up to 8-hour outages. And just see, based on that sector, this is more commercial, industrial focused sector here, but how that can really have a significant impact on the operations and the value of companies as they continue to see outages there. When we look at CHP for resilience, the end user component here is really that key piece to make sure that you have the electricity and the thermal energy you need for that site. One of the areas we like to really emphasize is that when you are putting these systems in place, there's some key areas you need to be thinking about if you want the resilience piece there, as far as making sure it can operate in island mode when there is a utility outage, which means operate isolation from the grid. It must be able to have black start capability, so when that grid goes down, it has to start back up again. And so just some key areas to be thinking about that we've seen some CHP systems go in place that do not have that capability. And when the power goes out, they have to go down as well, or they go down as well. Once again, for utilities, they really see the opportunity around grid congestion and grid stability. And for communities, most of the focus is, of course, on critical infrastructure. And I said earlier, we're doing some studies now. We've actually did, I guess, 4 studies last year looking at the resilience of critical infrastructure across. These were kind of mid-sized towns there, and prioritize what the resilience of their different critical infrastructure assets look like, and help them prioritize and figure out which ones they need to be focusing on in order to kind of ensure they remain online when there are power outages. And so that's just kind of an ongoing focus that we're seeing right now. Just some examples of where some of the critical infrastructure is going in, and this really came across much smaller than I anticipated, but this is just examples of where we're seeing critical infrastructure: schools, colleges and universities, wastewater treatment plants, hospitals, nursing homes, lodging. That's where most of those sites are coming in there and are conducive to CHP based on the load profile that they have there. This came out of the Department of Energy Resilience Accelerator that wrapped up a few years ago. This one's largely focused on what are the different types of distributed energy resources. So you see those on the left: battery storage, biomass CHP, down to natural gas CHP, standby generators, and the different types of events that they focus, from flooding over to extreme temperature there. And anything it's a hollow circle there means they're not impacted by fuel supply interruption or damage to equipment or performance limitations or planned or forced shutdowns there by any of these factors. The ones that are solid circles means they're pretty much experience all 4 of these impacts there. So in any case, as indicated here, natural gas CHP seems to have a pretty good opportunity there to survive and continue to maintain operation during these major events there. It's just kind of good to kind of demonstrate how these different resources are able to respond, especially when you're talking in coastal Houston or coastal Texas. That flooding can be a real issue. High winds, of course, storm surge and such. I kind of touched on this earlier just a second ago, and actually I have 2 more slides before Doug comes up and really gives you the great example of how great CHP works, but just want to give you 2 more quick slides on this. First of all, we run into this quite a bit when people are looking at critical infrastructure and backup generation. And we talk to them about CHP. You know, when you talk about putting in a diesel generator, there's some significant issues on fuel sources, as well as the reliability of these systems, especially if they're not properly maintained. With CHP systems, you have that 24/7 operation, and you really have, so you know that system's operating, you can receive benefit from it on an ongoing basis, and you reduce a lot of uncertainty in operation. Just some of the key issues there, of course, is that when you look at the fuel supply, that natural gas infrastructure is very robust, especially in the state of Texas. It's been proven very resilient and very reliable. So really very minimal fuel supply concerns here in the state. So I kind of covered some of these other areas. I don't want to beat too much because I want to get you guys to Doug here. The final thing here, and this is, of course, in Houston, this is the Texas Medical Center. And they have done a really nice job with their CHP district energy system to kind of keep it safe from the storm. UTMB, University of Texas Medical Branch in Galveston, has done some great work for their CHP system. They have 2 CHP systems down there. They were built after Hurricane Ike wiped out the hospital. They were up and running during Hurricane Harvey, and the hospital did not lose power. It did not stop operations. And that's largely because that design criteria they used made sure that it was above storm surge levels, above flood levels, and they put the appropriate mechanisms in place and infrastructure in place in order to keep those systems resilient. So that's just really key, as we're seeing a growing number of extreme weather events, to really take that into consideration and make sure that critical infrastructure is properly secure and in place there. All right, so I'm gonna switch over to Doug here, or I'm gonna stop sharing, and Doug is gonna grab the screen here and start talking about Wesleyan University.
All right, thanks, Gavin. Really appreciate that. I think that was a great overview. Makes my job a lot easier. So let me just pull up my slides.
While we're transitioning, just to reaffirm, recording and presentation slides will be emailed to attendees to the email address associated with your registration. So I did see some Gmail accounts on the list. So if you don't receive it in your work email, check any other emails you might have.
All right, Cassie, am I displaying correctly on your end?
You are perfect.
All right, great. Well, and thank you for the opportunity to present today to your network and your community. I haven't met a lot of you folks, so I'm excited to present this case study on CHP. I think Gavin did a great job in setting the grounds for what CHP is. So this will be hopefully informative and helpful if you're looking at CHP at your own facility or other facilities. So Texas Wesleyan, for those who don't know, is located in Fort Worth, Texas. It's a private university with about 3,500 students and I think over 50 standalone buildings. So it's a fairly small campus, but a lot of standalone buildings. So most of those are on the same electrical distribution. Most of those are all on a district hot water loop, and most of those are also on the same district chilled water loop. But before we get into the details of the CHP system, I'd like to give just a quick introduction of who I am and who we are and how we're connected to Texas Wesleyan. So, we're a fairly young company, but the leadership team has over 20 years of experience in the power industry, utility scale, all the way down to residential scale. I personally sit in Dallas, Texas, and we focus on being a DER and CHP solutions provider. And we do that by 3 primary focuses, and that's planning, execution, and operations. So in the planning phase, we do things similar to Gavin and his group. We'll do feasibility studies, conceptual design. In the execution phase, we can supply equipment. We can help with project management, construction management, owner's engineer, independent engineer. And then the operations is what I think is our biggest and gives us the most key insights into what we do is operations and maintenance. We can come alongside you and the asset owner and operate and maintain the facility on your behalf. And we really feel like that gives us a lot of insight into the other business areas, meaning, and I'll give one example. When we do a feasibility study, we routinely assume early on that we would be asked to operate and maintain that facility. So what that does is gives us the ability to say, what are reasonable assumptions on performance and financials, downtime, planned and unplanned. And so we really, we want to make sure that we're reasonable, because if we're going to be the one who runs this system long term, we certainly want to meet the expectations that are set in the beginning. So we think that helps us have goal congruence with whoever the asset owner is. So that leads us to our relationship with Texas Wesleyan. So for Texas Wesleyan, we are the service provider for the CHP system. So we handle planned maintenance, and we also help them with unplanned maintenance. So when we go through the example, the design, you can consider that firsthand knowledge. Some of the background, such as the project goals and early on and the financials, you can consider that secondhand knowledge, and I'll do my best to explain what I know and hopefully answer any questions you guys have on that side. So let's start with, why did Texas Wesleyan do a CHP in the first place? Well, it was part of a broader capital improvement plan over multiple years with a focus on sustainability. And I'll really boil those down to 4 categories. One major one was to reduce costs on utility spending, not only electricity and gas, but also their water consumption. They wanted to catch up on deferred maintenance, and they wanted to improve resiliency, the reliability, redundancy, and efficiency improvements. And then the last category is they wanted, I'll call it the human touch, or the goodwill category. You know, knowing that they are an academic facility and they are a big component of the community and their brand matters, they wanted to be a community leader and engage with the community and a good steward of their campus. So those were the goals, and that's how we got to CHP. So what is it? They elected to self-generate a portion of their power. So they installed an 800 kilowatt reciprocating engine CHP system packaged by 2G Energy. They installed additional cooling capacity in the form of an absorption chiller, which Gavin briefly mentioned. They also replaced boilers and added redundancy in the boiler system. And some of the other things, there's a whole bunch of other things that I'm not necessarily privy to, but they replaced variable frequency drives on air handlers and motors. They did some retro commissioning. And then there was LED lighting upgrades, automation upgrades, a new BAS system. So there was a whole bunch of other things that outside of the CHP system as part of this major plan. So as I go through the design, if you're like me, a picture is worth a lot. And so I've got a few pictures to show you what this equipment looks like. And so in front of you is a packaged CHP system. So, and I got a couple pictures inside the container, but what you're looking at there in the green container is 2/3 of that is an engine room and 1/3 is a control room. The items on top are supply and intake and exhaust ductwork, a stack, a silencer, and that white thing on the left top is a radiator to dump unused heat to keep the engine cool. And so when you think of packaging, which I know is something the DOE is very keen on, what we're trying to accomplish is doing more of the construction and fabrication in a factory, testing it wholly in the factory, and then delivering it into the site in modular pieces. So an installation like this, I would imagine maybe 2, maybe 3 trucks to deliver this system to site. And if your logistics are correct and well managed, you could easily install this and have it buttoned up in about 1 day, 2 at max. So it really cuts down on construction time and installation time to do a packaged product. So a couple images inside the package. What you're looking here is an MWM 2016 V16 engine, meaning it's got 16 cylinders in a V configuration. Behind the picture taker, unfortunately I don't have a picture of it, would be the control room, which is about 1/3 of that container. And it houses all the electronics, the PLC, the VFDs, and even includes an extension of the oil tank. So it's, you know, there's quite a bit of piping and valves and pump that go inside this container. Next door to the packaged CHP system is where the absorption chiller is housed. It's 250 tons. It's supplied by Carrier. I believe it's a Thermax absorption chiller. And also next door is the new Raypack non-condensing hot water boilers. Sandwiched in between those boilers is a plate and frame heat exchanger. And I'm going to spend a lot of time on how all these devices are interconnected. But I wanted you to see a picture of what these items look like. And you'll notice in this picture, both boilers were under maintenance at the time of this picture, and the CHP system was providing all the heat to the campus in the meantime. So that you can already get the sense of the redundancy that the CHP system provides. So I've got a simple design on the electrical and gas side. I'm not going to spend too much time because it's very traditional for a CHP system, so I'm not going really get into the details. This is overly simplified, but it's 800 kilowatts of gross capacity. Some of that capacity is used for parasitic loads within the package itself. I would estimate about 5% of that is parasitic loads. It operates in parallel with the local utility grid, which means there's sensing equipment on the utility side that allows it to sense frequency and voltage so that we can match and synchronize to the grid. Unfortunately, there's no exporting of electricity. If you're familiar with this area, the surrounding area, for lack of a better word, has some fragile infrastructure. So exporting electricity would have been cost prohibitive. So our sensing equipment also helps us prevent us from backfeeding into the grid. And within some of the dedicated gear, there is relays and relay protection. That's to protect not only the generator, but also the utility, just as I mentioned. And on the natural gas side, it's very simple. There was already a natural gas network for their existing boilers. So just a new branch with a new meter, and no need for gas compression, as 3 to 5 PSI is adequate for reciprocating engines at this size. So here's now we're at the fun part of the presentation. That's the thermal side. So I know this can look a little intimidating, so I'll try my best to explain it as best I can. I'll start from the left. The CHP system generates hot water using two things. One is the exhaust from the engine itself it's about 50% of the recoverable heat. And the other 50% is in the engine jacket itself and the coolant system. So just like in your car, you got to keep your engine, you don't want your engine to overheat. Same thing with these engines as well. So there's a coolant system that we can exchange heat with. We send that hot water to either the absorber or to the plate and frame heat exchanger. And I'll skip the absorber for now and talk a little bit about the boilers. Boiler 1 can send its heat to either the absorber, or it can send its heat to the district heating loop throughout the campus. Then the plate and frame heat exchanger is really only used with the CHP system, and boiler 2 is a completely backup system that would just be used as added capacity or redundancy for the district heating loop around the campus. And what you see here are pumps and valves. This is simplified, so they may not actually be exactly as drawn, but for purposes of today, I thought they would be helpful. So I've got two operating modes, if you will. I think there's much more than two. But in the winter time, they use this system to do space heating. So what would that look like? Well, the pumps here, green means on, and the valves, green means open, red means closed, or red means not operating. So for the CHP system, sends its hot water to the plate and frame heat exchanger, where it exchanges its heat with the building, the utility loop, the district heating hot water loop throughout the campus. And the absorber's off, and boiler 1's not needed, and boiler 2's not needed. In the summer when we do space cooling, the CHP could send its hot water to the absorber. The absorber could, through a series of heat exchanges, create chilled water to be sent throughout its chilled water district circuit. And I'm just showing that boiler 2, or even boiler 1 for that matter, could be operating even in the summer to do some air conditioning, reheating if needed. So I know a lot of folks are probably interested of, what was the cost savings involved with this project, and I can provide you with what I was made aware of in the beginning stages. I'll tell you that it's changed somewhat with COVID-19, and we'll get into some of that in a minute. But these were the early financial savings basis. So there was an assumption that it would run 6,000 hours a year at an average output about 550. We know now, after operating after 2 years, that it's more like 750. For most of the year, this engine can run at or near full load on a normal year. COVID-19 has changed some things, and we can discuss that a little bit as well. But taking in other parameters such as the gas consumption, cost of gas, cost of electricity, your maintenance cost, and the value of the heat recovery. The university was presented with some numbers shown here. And what was shown was a matrix of what would the savings be, giving a certain set of parameters. and looking at, well, what if the value of electricity changed on a cents per kilowatt hour or dollars per kilowatt hour? And what if the cost of gas changed on a dollars per MMBTU basis? What's shown here is 150,000 a year, but I can tell you, I think it has been more because, like I said, the system actually generates higher than what expected. And I think 6,000 hours is actually quite low, although that is what we have seen. 2019, because of COVID, 2020 because of COVID-19. And in the summer, there was a maintenance event, and because of the disruption in business continuity, there was an election to defer maintenance on the CHP system. So for a good part of the summer, the CHP system stood idle. So unfortunately, we're averaging 6,000 hours, but I think if we get back to normal, we can be well above that. So, I'd be hard pressed not to mention some challenges ahead. I've already mentioned COVID-19, which I'm sure has impacted most of us. But currently, there are less students. Last I heard, there were no students. That may have changed recently, and very little staff on campus. So what that means is there's been very little demand for electricity. And that has caused the CHP system to run at unexpected lower part loads. And here in the winter, we've even seen the CHP shut down every night, which just, we as the service partner are looking at ways to reduce the number of starts and stops. It's never necessarily a good thing for equipment. Other challenges we see is the local operators and technicians are on some reduced man-hour schedules, one on, one off, to combat COVID-19. And, the challenge we have now is giving that, where we're at, trying to really minimize how much additional maintenance gets delayed and deferred in the future. We really want to see the university capture as much savings as possible, but also run the engine at a healthy load. So hopefully this has been informative, and I think Gavin has a couple more things to say as we wrap up. And if you got any questions, I'd be happy to answer them. And if you'd like more detail, I'm sure Cassie and Gavin can get you in touch with me, and I'm happy to go a deeper dive into the CHP system.
Hitting wrong buttons. All right, thanks, Doug. Appreciate it. Great overview, and it's a really cool system there. And it looks like you've generated some questions, which is going to be really nice here in the discussion here in a second. What I wanted to do now is just kind of give you some overview about the CHP TAP. So we've been around for quite a while now, different names, but now known as the CHP Technical Assistance Partnership. We do a lot of work in this regard as far as just engagements. If it's a webinar, we used to do a bunch of tours. I'm going to try to do that. And actually, we've toured Wesleyan in the past and did kind of a lunch and learn there. It's a very nice site. Do a lot of just general conferences, as well as just kind of dedicated meetings, trainings. We work closely with different utilities, especially natural gas utilities, as far as just providing training opportunities in that regard as well. But a lot of it is really just to kind of provide the material and resources that people can use to make decisions. And I'll cover some of those resources in a minute. But we're also there just to also provide technical services. We do a lot of work on just what's kind of these early stage screenings, so just kind of standard technical assistance where we do an economic development or an economic model that allows you to kind of use it as a planning document to figure out, is CHP worth considering or not? And this is actually kind of what we're thinking about. Is we have these quick screening questions that we run through. We gather some utility bill data. So many of you are probably facility or energy managers, or I know are likely energy managers and facility managers. And so you have access to a lot of this data. So we asked for that 12 months of data. We also asked for some operational parameters on the building, some of the thermal and cooling numbers associated with the building. And we can then provide a pretty high level idea as far as whether or not CHP is a good fit. If it's a good fit, we kind of then help work through the entire project development process as far as identifying vendors, engineering companies. For those, of course, most of you are in the public space, working with you to kind of work through the RFP, RFQ process, making sure the right questions are being asked, helping with the review process in that regard. We can't, specifically choose any vendors, but we can at least make sure that the RFQ process is going down the right road, and you're going to get the information you need to make those decisions there. We help with a lot of the investment grade analysis as far as doing third-party review of that. We're not design engineer company by any means, but we do look at a lot of design and engineering drawings, and we look at the investment grade audits and make sure that everything's kind of copacetic there and working in the direction to expect. And then also just helping with some of the ideas around, what are different incentives and rebates that are available? What do we need to think about on the interconnection process, the permitting process, those types of things there. So anyway, kind of help work through that that entire process and kind of just be that support mechanism there and that resource to help people work through this. Just to give you a quick idea, these are all the different TAPs that are out there. Of course, we're largely focused on Texas here, so we run the Southcentral TAP as well as the Upper West TAP. So we have about 11 states, pretty wide coverage here. But these TAPs are around the country and are full of experts and people that are very much understand what's happening in their markets and can support CHP development in that regard. What we have, just wanted to show you some resources. There's this great installation database, and we've reached out to several of you in the past that are on the call just to see what's happening with your existing CHP systems, because we like to know what's being installed and the types of systems and how they're being used and if they're critical infrastructure or not. And that just really gives a good view of the state of the market there. EPA has come out and developed a much improved CHP policies and incentive database. Many of you are probably familiar with Desire. We do not use Desire as much anymore. It just kind of has lost some of its funding and support. So we saw that EPA kind of stood up to the plate there and really developed a robust policies and incentive database that's really useful for folks. Some of the other areas, especially to those that are new to CHP, some great issue briefs that are coming out, looking at resilience planning as well as financial, or as far as financing your CHP system. There's also a nice report that's been out for several years now, but if you're trying to build that business case for CHP and trying to convince your chief financial officer or finance director or just whoever your immediate supervisor is who may not be certain what CHP is, this report is a nice job on kind of just doing a high level discussion of that. Some of the other things we have, these fact sheets, these really cover all the prime mover technologies. So from reciprocating engines to gas turbines, steam generators, microturbines, fuel cells, just give you an idea of where they are most applicable based on typically kind of on the quality of the heat or type of heat that's coming out of them, their ownership and operation and maintenance costs, installation costs, and just kind of a general idea of where would be best to use those systems. There's also a state of CHP resource that we have here. Of course, there's one on Texas. It kind of walks through all the technical potential and opportunities across the states. Nice little just fact sheets there that we use. We really like to promote these. We actually have a large number of these project profiles, I think over 240 or so. We did one on Wesleyan University, but we do them across a variety of, well, we pretty much do as many as we can. So anytime we find a good project, we try to do a project profile on it because people are always looking for what are those best practices, what are the lessons learned, and then the basic specs on the project, how large is it, what's it used for, what kind of equipment is in there, how much savings is it seen. And so these project profiles do a real nice job in that regard. And they're only a couple pages or one page front and back. Same with the policy program profiles. Really try to highlight what kind of programs and opportunities are out there that can help people better understand what that CHP market looks like. We did a couple for the state of Texas. One is the permit by rule that's within the state that really helps facilitate the installation of CHP for smaller CHP systems there. And then also a critical infrastructure profile we did recently as well there. But anyway, another additional resource in that regard. One of the things that we kind of emphasized in this presentation was the importance of resilience planning. And as I said, we've done a bunch of this with communities in the last year or so, most of them in our upper West region, but now we're doing 2 large cities down in Texas and over in Louisiana. This is largely kind of helping to better understand what that resilience looks like. How do you prioritize your critical infrastructure resources? what steps can be taken in that regard. And as you see, it's DG. So it's not just CHP, it's CHP with solar and storage and any other potential distributed generation resource that may work at your site there. This critical infrastructure paper on the right came out right after Superstorm Sandy, and really just kind of demonstrates both the impacts, the significant negative impacts that Sandy had on the power infrastructure and grid, but also the reliability and resilience of a lot of the CHP systems that continue to operate. Texas is highlighted in there for its best practices and critical infrastructure policy. So, excuse me. Next steps, what we always like to do, kind of a call to action at the end here. Once again, we're a no-cost resource. We're funded by the Department of Energy to help run through and better understand if CHP is a good fit. So we can do these no-cost qualification screenings for your facility. We end up doing about 60 or so of them a year. So we're happy to help and support in that regard. And just largely just to summarize here, CHP, it's a proven technology. It's really expanding its applicability and availability across a variety of different resources. There's a lot of different drivers pushing it. If you're looking at renewable energy integration, if you're looking at microgrids, if you're looking at resilience and reliability, a lot of great ways in which to really have CHP come in and be a part of that, part of your facility, part of your site or your campus there. So that's it. I wanted to just kind of wrap it up from there, and look forward to answering any questions, and appreciate the opportunity today.
Great. Thank you so much, Gavin. And yes, extremely informative, and just always impressed at the array of resources that DOE and EPA make available to support all of our energy and sustainability goals. And really they're not utilized enough nationally. So glad to get the word out on those today. We do have a ton of questions, and really great questions. We only have a few more minutes. I'm going to try and grab, maybe one or two technical ones, one or two more general ones. So we had an early question about, is the absorption chiller only used to cool the generator? Doug answered that the absorption chiller is used to create chilled water for the campus district cooling loop. The hot water return from the absorption is low enough to also keep the engine cool. Another question from the same person. If I'm interpreting these acronyms correctly, operates only GC, no SA availability. Is that grid connected, not standalone availability? Doug, does that mean something to you?
Yes, it does. Sorry, I think I was on mute.
Yeah.
It is only, in this particular case, it is only grid connected. There's no island mode capability. The 800 kilowatts would not cover the full load of the entire campus, and there is not load shedding protocols in place to shed non-critical loads to allow it to island mode safely. If they elected to do so in the future, it could be done. It's just not set up for that as of right now.
Great, thank you. I want to pick up a question for Gavin about, I'll just read it out to y'all. If a community was interested in microgrids and CHP as a strategy for resiliency of their critical infrastructure against natural disasters, ideally, who are the stakeholders that should be involved in the education and planning process? And do you have case studies of communities who have used microgrids as a strategy for resiliency of key infrastructure against natural disasters? And Gavin, I'm just going to tack on to that a little bit. Can you put a little bit more color on a CHP that is used kind of by multiple end users, if you have any examples of that? Because it seems like a lot of what we've been talking about is campus, single owner user. So do you have any examples of more kind of community and district scale systems?
Yeah, absolutely. So, so just kind of start from the beginning there. One of the key stakeholders is your local CHP TAP, because we can help you run through the resilience criteria there and help you kind of figure out what is your critical infrastructure and how to best improve the resilience of it. but it's largely in who we're working with now. One of the cities we're working with now, it's working with the facilities department. It's working with their Homeland Security department. It's working with the finance folks, and it's also working with those that negotiate the energy contracts. It's also key, based on where you're going to be placing that site, to engage with the community itself. So we do talk with community leaders in sites that look like there could be a CHP application, to let them know that this could be potentially, if this would be a good site for them, especially if it looks like it could be a good shelter during a hurricane or during some sort of major natural disaster outage. So we do engage kind of community leaders, if those are if they end up being the church leaders, or they run a specific kind of nonprofit that's supporting the community, or community-based organizations. So we have reached out to those groups as well. But most of the critical infrastructure stuff largely kind of involves, kind of those key city departments, or the key departments that are focusing on the Homeland Security side, the financing, the energy, and the facility folks there. Probably as far as just a site that has multiple separate separate entities would be the Texas Medical Center, the TICO site that operates. I don't have the exact number of different entities, but there's at least 24 separate entities that are connected to that system. So it's not like it's Rice University that is all owned by Rice and it's all Rice buildings. This is the Texas Medical Center. They're all different buildings owned by different operators, but they've all decided to plug into that CHP district energy system there. So that would be kind of the closest one that's just coming off the top of my head. There's several across the country that we've worked on and have looked at. There was probably another closer one. There's one in Colorado that's being developed that's actually for a kind of a mid-sized town. A mid-sized town in Colorado that's developing one that is essentially their central business district that they're putting in the CHP system there. But closer to home in Texas would be the TICO one.
And who owns these systems in those cases?
For the one in the one at the Texas Medical Center, there's an organization or corporation that was created called TICO that owns and operates that system, and then people contract with them to hook up to that system there.
Okay. We have so many great questions and only one more minute. Maybe we can quickly grab one more and then follow up with some of these questions via email. Our speakers will be available on email afterwards. But maybe can you speak very briefly to, are any of these systems being used for transportation and commercial fleets? I really love this question because it's the merging of two really important innovation areas.
Being used for transportation or commercial fleets. I would have to kind of dive into that and look through our database and see which ones are being used in that regard. And I'm assuming largely, is that kind of within the maintenance facilities, or is that for EV charging, or kind of what's
for both? It looks like the question is for both charging and including fuel cell vehicles, and then it's in admin facilities.
Yeah, I don't have one off the top of my head. Doug, do you know of any that are?
No, I have not personally been involved in projects like that as well. We don't get too many requests from the transportation sector.
Well, I know the person asking, and I won't reveal who it is, but he is a thought leader in the area, I would say. So glad to have the question. Okay, well,
very good question.
I will record these questions that are left, and I guess if you want to reach out to the speakers directly with these questions, they are really great, but unfortunately we are out of time. So thank you all for coming. I will send out an email following this with contact information, the presentation, and the recording and the survey for those CEUs. So thanks you all for coming. Gavin, Doug, thank you so much for your work and expertise, and we'll see you all next time.
All right. Thank you, Cassidy.
Thank you.
Thanks, everybody.